Hello everyone, welcome. Today I thought I would take a little bit of time to talk about things the book talks about, but in a little different way, and to give you some examples of how these arrays, which we are now collecting data, right? Last week we collected statements into methods. This week we are starting to collect data into an array. So I thought I would talk about arrays a little bit more from a conceptual point of view than the book. And I thought I would hit on some things that we have talked about previously, but you can really see them with arrays. In particular, some numerical calculations and involving floating point numbers. I've said earlier that floating point numbers are stored in something akin to scientific notation, and we have a fixed number of significant digits and then an exponent. And whenever you say fixed number of significant digits, we are approximating the mathematical concept that we have an infinite number of digits out to the right of the decimal. Well, we don't. We have a fixed number, so we are approximating something that's infinite by something that's finite, which introduces error, and we're going to try to see some of that error. And I also thought I would talk about call by value a little more, because we can really see in arrays some implications of call by value that we couldn't see when we were just talking about simple scalars or regular variables and things like that. So to begin, this is a pillbox that old people like me use, and we will define an array in Java as a fixed size, randomly accessible, homogeneous collection of elements. So let's think about this pillbox as being all those things. It is fixed size. This pillbox was made with 7 boxes. It could have been made with 8. It could have been made with 6. It was made with 7. Once it's made, it's done. I can't expand it. I can't shrink it. It's 7 boxes. So when we create an array, whatever size we created, that's it. It's fixed. If I need more, I have to allocate a new array that's bigger and copy all these things from the old array into the new array. I can't expand an array once it's made. Similarly, I can't shrink it either. An array is randomly accessible, sort of like this pillbox. If I only need my pills on Tuesdays and Thursdays, I can use those 2 boxes and completely ignore all the others. And so not everything we're going to study this semester is going to be randomly accessible like that, where I can just ignore things. But an array is, just like this pillbox. Now, the homogeneous is where the analogy starts breaking down. If this pillbox were a homogeneous collection of elements, I could only put 1 pill in each box. It doesn't have to have a pill in it, but if it has, it only has 1, and all the boxes have to have a pill of the same type or be empty. So that's what we mean by homogeneous. All the elements have to be of the same type. Now, as this being Java, and Java is a zero origin language, we're going to say that this first position in the array is 0. This is a 1-week pillbox, so we know that the number of boxes is 7, but the first one's 0, 1, 2, 3, 4, 5, 6. So a 7-element array has indices of 0 through 6. Very similar to strings when we were doing the char at. Strings have a length, and their positions are from 0 to length -1. In fact, a lot of the processing that you did with char at is going to come over pretty directly into how we manipulate arrays and elements in arrays. The syntax is different, but the concepts are the same. If I want the third element, then that would be element number 2 here, because 0, 1, 2. So that's the mental picture I carry around when I'm thinking of an array. A fixed size, randomly accessible, homogeneous collection of elements, sort of like my pillbox. Now I would like to move and let's talk about double floating point numbers and calculating them, because we can now aggregate them and we can see how some of those warnings that we gave you about floating point a couple of weeks ago that most people ignore, but they really are important. So we're going to see them. And let me share my screen. And I hope you can see Eclipse here. And let me make this a bit bigger. So what's going on here is I have a method called makeInit. It is here. And what it does is it creates a new array of array size elements. Up here, I have a constant array size of 5. Now I'll be changing this later on, but for the moment, it'll be 5. And I am going to assign each of those elements in that array size a random number between 0 and 1. Pretty simple stuff. So here I have an array of random numbers between 0 and 1, and I print them out. My string to print method prints prints an array element unless it's too big, at which point it just says, well, it's too long, I didn't read that. But if it's short, and 5 is short, it will print the elements. So here I have my array of random numbers. I print them, maybe. Now I create a new array called small to large. I copy the random elements in it, and then I have the selection sort code from the book, and I execute selection sort so that my small to large array now is sorted, smallest number first to largest number. Now I make a third array called backward sorted, and I have a reverse method here which will reverse my small to large array, and you're going to write that as part of your stuff in the book. So now I have 3 arrays with the same numbers in them. I have the arrays in random order. I have the arrays, I have the numbers in small to large order, and I have the numbers in large to small order. Same numbers. So we would expect that if we say took an average of those numbers, we should get the same result. That's what our expectation would be. So let's just first run this, and then we'll make it more interesting. And I wonder, can I make this bigger? There we go. And I'll try to make this bigger too. So let's run this just as far as we have it and see what happens. So here are my 3 arrays. I start out with 0.07, 189, 191, 394, 146. So the 0.07, the 194, 189, 191, 394, those are sorted, smallest to largest. And these are sorted, same numbers, exactly the same number, largest to smallest. So let's now take the average of these three arrays and see what we get. But before we do that, we're going to make it a little more interesting. Instead of 5 elements in the array, let's go up to 100,000. And let's run it again. And this will take a little while to sort. And you see that I mercifully did not print all 100,000 elements 3 times. But down here, I do have an average method. And my average method takes an array, totals it up, and divides it by the array length. By the way, you always know the length of any array in Java. It's the array name dot length. That's not a method. There's no parentheses here. I don't know why they didn't make it a method, but anyway, it is what it is. Array dot length will tell you the length of whatever array it is that you're talking about. But now let's look at these averages. The random ordering got that average, which is fine, and these guys are really close. They are identical. I don't know how many digits that is. I'll leave counting them up as an exercise to the reader. But they are only very slightly different, but they are different. And so this is why we tell you don't compare floating point numbers such as double or float with using equals equals or not equals. Always subtract them, take the absolute value, and then find out if that difference, if that absolute value is really, really close to 0. And what really, really close to 0 means, it depends on your application. But here you could see that they are many, many digits equal, many digits past the decimal, but they're not identical. These numbers would not compare equally. So this is an area of computer science referred to as numerical computation, sort of getting into a little bit of numerical analysis, but not much. And it's how error can grow in your calculation because the numbers we have to work with are not exact in the mathematical sense. They are approximations, and approximation leads to error. So let's work our way through this program a little bit more. And here we're going to start working with call by value. So I have a method called add 5, and add 5 again takes an array, adds 5 to every element. Not much to that. And now I have a method called by value, and I'm passing this backward sorted array into it. And this was the method that I just added 5 to each of the elements. And let me switch back to using an array size of 5 right here. And where am I? So I've added 5 to each of these elements. I've called by value. So now let's look at what by value is going to do to us. It takes an array and it immediately adds 5 to every element. Then it does something new. It creates a new array, which is twice as long as the old one. And I initialize each value of that new array to -5. And then we print stuff out. And notice that we have the eye catchers indicating that we're in the by value method here. So that as we go up, we do the call, and then we print out backward sorted. So let's see what happens when we run this. So here are our random averages. Interestingly enough, these are a lot closer. Well, we're only using 5 elements. And yeah, the may not have had as much opportunity for error to creep in as if we'd used more. But we add 5 to each of the elements in the backward array. So I have 5.8, 5.63, 560, 5277, and 5274. Fine. Still ordered back to front, though that doesn't matter. But they now have had 5 added to them. Now in the by value method, this array size is listed as 10. Which, okay, this was 5, so I doubled it and I created an array of 10 elements, and I set each of them equal to -5. That makes a lot of sense. And all this stuff is the result of those 2 system out print lines right there. So fine, things are as they were. But now I'm going to hit the end of this method and return, and I return here, and now I print out backward sorted again with the eye catcher saying after by value. So after by value, my backward array is no longer the 5.8, 563, it's now 10.8, 10.63, and so forth, and there are only 5 elements. So what's going on with this? Let me see if I can explain it a little bit. And I hope this is big enough to read. In my main method, I had a backward sorted array, and arrays are objects like strings. So this backward sorted variable is just a pointer. Java has pointers, it just doesn't let us get to them very directly. But this backward sorted variable is a pointer, and it points to, this is an area called a heap. It points to this object. This is one object. Not drawn very well, but sorry about that. And it has some numbers in it. And since we're using random numbers, there's no way I could predict what numbers were going to appear here, except that they were all going to be 5 point something. So I have this backward sorted variable, and it points to this object. And then I hit my by value call with the actual parameter of backward sorted. The value of this backward sorted pointer is copied into my formal parameter here called ARR. So that is going to set up a correspondence between ARR and this same object there. So when I add 5 to ARR, I follow this pointer and I'm changing these elements to 10 point whatever. There. Okay. So add 5 has changed my array. Now in by value, I hit the statement where I am creating a new array. What happens there is the new operand makes a new object over here, and it's going to have, remember, it was twice the size of the input array, and so it's going to have some values and ... because you don't want to sit there and watch me type all day. And so I am now going to have a new array over here with 10 values and some values in them. And I'm setting our ARR to point to that new array. So this pointer right here is blown away. It is no more. And ARR points there. And when I printed the ARR value in my by value method, we saw that it had 10 elements, and oh yeah, they were all set to -5, weren't they? So we saw that we had 10 elements and they were all -5 in this method. But then we progress and we hit the return for this by value method. And what happens then is I start unwinding all this stuff. But this relationship is deleted because everything in this by value method goes away. In the main method, when I print backward sorted, notice backward sorted is still pointing to this old array. This is the thing about call by value, and especially using call by value when you're pointing to objects. There is nothing this by value method can do to change what backward sorted is pointing to, the object that backward sorted is pointing to. So when I print backward sorted here, I'm going to get my 5-element array. But by value, while it can't change the object in the caller, it can go into that object and change its contents. It can really mess up its elements, because this was 5.7, 5.6 before the call. After by values return, because of this add 5 array call here, it's now 10.7, 10.6, and so forth. So that's a subtlety that people have some trouble with early on, and I wanted to warn you about it. We will see this kind of thing happening again. And as we move into objects and writing classes and so forth after the midterm, this is going to become more and more and more important to understand. So I hope this helps. We went over the definition of arrays very simply: a fixed size, randomly accessible, homogeneous collection of elements. We also went over why, as I tell some of my math friends, addition in a computer is commutative mostly, but not absolutely. And that is why we can get different averages from the same set of numbers, the only difference being the order in which we sum up those numbers or do our calculations. And we also looked at what happens when we use call by value, and the fact that we cannot change what object our caller is pointing to, but we can go in and what's referred to as mutate the contents of that object. So I hope this helps. Things are getting better and better. Study hard for the midterm. Don't forget the Respondus browser requirement, and the fact that you can pick up an extra optional lab by doing the Respondus browser test. The instructions are all in Blackboard. So talk to you later. Bye.